students, time for another math assignment. This is 8.3.3. That means 8th grade math, Unit 3, Lesson 3. Let's get started. Do you have your pen and paper ready to take notes? Remember, you should always take notes in order to learn any subject. Okay, read problem number 1. It says, here is a graph of the proportional relationship between calories and grams of fish. I like fish. Okay, so what can you see from this graph? If there are 0 grams of fish, there are 0 calories. That makes sense. 100 grams of fish is 150 calories. 300 grams of fish is 450 calories. Okay, easy enough, I got it. It says, write an equation that reflects this relationship using X to represent the amount of fish in grams and Y to represent the number of calories. Okay, I want you to get your piece of paper, get your note page. And this is problem 1. Write that on your paper because I'm checking your work. Problem 1. Okay, the first thing it told you was that X equals grams of fish. So I'm going to put that like this. I'm going to write fish, and the unit is grams, like that. And the next thing they told you was Y represents the number of calories. So Y, I'll just put calories, and that is the unit. Calories, sorry, my writing is not that good. You know, we could call that energy and the unit is calories. Anyway, whatever. Okay, they asked us to write an equation that reflects this relationship. Remember, our equations for proportional relationships take the form y equals k times x, where k is a rate, sometimes called the proportional constant. Okay, so what is that rate going to be? Well, in every proportional relationship, that k equals the change in the value of y for every change in x. So for this, it's going to be how many calories for how many grams of fish. Grams of fish. How many calories for how many grams of fish? Okay, so look again at the graph. What information did we learn? We learned that 100 grams of fish is 150 calories. I'm going to write that right here. Right here. 100 grams of fish is 150 calories. Okay? I got that note right here. And we also learned that 200 grams of fish is 300 calories. You know what? That's easy for me to remember. 200 grams of fish is 300 calories. I like those numbers better. Let's use that on our notes. So that's what our rate equals. I'm just going to jump right ahead and tell you that's what our rate equals. It equals 300 calories for every 200 grams of fish. Wait, 2 fish? No. I better change that. 200 grams. I'll just put 200 grams. Oh no, I forgot my zeros. Oh, that looks messy. Don't let your notes get messy like mine. Let me write that again. 300 calories for every 200 grams of fish. Okay, that is a rate, but we don't want to use it, well, we probably don't want to use it in this form. We need to reduce this fraction. So you can just divide off these zeros, and this fraction reduces to 3 over 2. So that's our rate. Every 2 grams of fish has 3 calories. And now pop that rate into our equation. And you get the answer, y equals 3 over 2x. And what does that mean? That means for every x grams of fish, you have 3 halves calories. 3 halves calories. Okay, let me show you some data points. Let's use 100. Let's say we have x equals 100. So I'll put 100 in here. If we have 100 grams of fish times 3, we get 300 over 2, and that is 150. So, let me carry down my y's here. Y equals 150 calories. That's what our equation means. Whatever grams of fish you have, pop it in there for x, solve for y to see how many calories it is. Okay, go ahead and enter your answer. Put your answer on the line here. And then let's go on to the next part. Use your equation to complete the table. Okay, if you have 1,000 grams of fish, how many calories will you have? And if you had 2,001 calories, then how many grams of fish do you have? And then if you have 1 gram of fish, how many calories is it? Use the equation, and I want you to do this in your notes. So for this one here, number 1, let's say we had 1,000 grams of fish, so pop that into your equation. The constant is 3 over 2, and multiply that by x equals 1,000 grams of fish. And your answer is 3 be 1,000, 3,000 be 1,500. The answer is 1,500 calories. And if you don't believe me, that's good, because I want you to do the math yourself. So you need to do that on your notes. Okay, how about this second one here? If you have 200 calories, how many grams of fish is it? Okay, you should be doing this in your notes. So now you have 2,001 calories. That is the y value. That's the y value. That's calories. Make sure you pay attention to the units so you know if that's your y value or if that's your x value. And then our rate constant was 3 over 2, which means 3 calories for every 2 grams of fish. How many grams of fish is that? So now we're solving for x. Do you know how to solve for x? Well, we want to isolate the x by itself so we know what it equals. So the 3 over 2 needs to move over to the other side of the equation. Do you remember how to do that? Whatever we do to one side of the equation, we must do on the other side of the equation. I want to cancel out this 3 over 2. How about I multiply by 2 over 3? If I multiply by 2 over 3, then this 2 and this 2 cancels out, and this 3 and this 3 cancels out. Don't believe me? Let me show you. Okay, 3 over 2x. And now I'm going to multiply by 2 over 3. Well, if I rewrote that, that would be 3 times 2 is 6. Right here, 3 times 2 is 6. And plus that x, 3 times x would be 6x. 3 times x times 2. Let me say that again. 3 times x times 2 is 6x. And then 2 times this 3, that is 6. So 6 over 6, that equals 1. So this equals 1x. That's why I'm multiplying by 2 over 3. And the 2's cancel out and the 3's cancel out. But I have to do the same thing on this side of the equation to keep the equation balanced. So 2, now let's multiply this. 2 times 2,001, that's 4,002. and the denominator is 3. It's still divided by 3, so I don't want to use my calculator yet, so I'm going to leave it as a fraction. That equals x. Okay, now I want you to reduce this fraction. Get your answer and show me the answer in your notes. X equals how many calories? Oh, no, not calories. Grams of fish. Please show your units so that I know you're following along. Okay, fill out your answers in that table. Don't just wait for me to do the work. Show me all the work in your notes and fill out the answers in the table. Let's go on to the second problem. Problem number 2. Students are selling raffle tickets for a school fundraiser. They cost $24 for every 10 raffle tickets they sell. Suppose M is the amount of money the students collect for selling R number of raffle tickets. Write an equation that reflects the relationship between M and R. Okay, so what information are we given? We're given that they collect $24 for every 10 raffle tickets. That sounds to me like a rate. Don't you agree? $24 for every 10 raffle tickets. I'm going to just jot that down right away. I don't want to lose that information. That's important. That's a rate. And if you reduce that fraction, what you get is 2.4. I wrote a 5. I meant 4. 2.4. And the units are dollars. $2.4 for each ticket, for each one ticket. Go ahead and reduce that fraction. You'll get the same thing. 24 divided by 10 is $2.4 per ticket. Okay, what else information did they give us? M is the amount of money. R is the number of raffle tickets. Okay, let's write this down in our notes. So now let's go to problem number 2. Can I just write P2? That's easy for me. And we learned that they earned $24 for selling 10 tickets. There we go. And we learned that M equals the money that they're earning. Write this in your notes. Always use your notes to show your learning. R equals the number of raffle tickets. It's very hard for me to write neatly with this pen tablet, so follow along and make sure you know what I'm talking about. Okay, we've got that information. Label and scale the axes, it says. Oh wait, I forgot to write the equation. Write the equation that reflects this relationship. Seems like I forgot what I was doing. Okay, normally we write our equations in the form y equals the rate times x. But we're not using y and x. We're using m and r. So which one of these is y and which one of these is x? Which one goes here and which one goes here? Well, look at the rate. The rate is $24 for 10 tickets, which I already showed you is $2.40 per one ticket. So our rate is money per ticket. That is like change in money is how much money they earn for every raffle ticket they sell. So the y value is on the top and the x is on the bottom. That's what our rate constant's always going to be, is the y value on the top and the x value on the bottom. So this is change in money. Let me circle it. Change in money per tickets. So in that case, we want money for our y value. And then our rate is 2.4, and r is our x value. Okay, there's the equation. Does it make sense to you? Make sure you understand this equation. And then type it in on the line here. Next, label and scale the axes and graph this situation with M on the vertical axis. Oh, now they're telling us that y equals m. M on the vertical axis and r on the horizontal axis. Okay, down here, this is r. Oops, I didn't write that neatly. Let me do it again. There we go. Make sure the scale is large enough to see how much money they would raise if they sell 1,000 tickets. Okay, back to scaling. Don't forget the importance of scaling. Scaling is like zooming into your graph or zooming out. And in this case, we're kind of zooming out. We want to go all the way up to 1,000 tickets. So what do you think our scale should be? Well, I mean, we're going up to 1,000. That's the scale. What should our individual tick marks be? I think, let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. There's 17 tick marks. So how many tickets for sale for each tick mark? Let's go 1,000 divided by 17. And what does that give us for how many tickets per tick mark? It says 58.8. Well, that number is not comfortable to work with. So I'll round it up to 60. Because I want to go up to 1,000. But we have 17 tick marks. So let's use 60 tickets per tick mark. This is 60. This is 120. This is 180. This is 240. You need to use the text tool to put these on the graph. Let me help you with that. After I erase my purple marks here. Okay, let me erase these. Now, get the ABC tool, the text tool, and this is 60. 60 tickets. Oh, it's hard to read, isn't it? It's right on the line. Let me move it down. Move tool, and then if you click it and just use the arrow keys, you can move it in small increments very nicely. Okay, so that's 60. This is 120, but I'm going to skip it and go up to 180 next. And 180, this would be 240, but I'm going to skip it and go to 300 next. I'm skipping some of the numbers because I don't want my graph to be too crowded. 300, so this is 360, and this is going to be 420. I don't want a crowded graph with numbers. It'll be too hard to read. 420, so now 480. We're just counting by 60s. And then 480, 540, and then 600 is here. There we go. And the next value is 660, but we're skipping it, so now 720. And then the next value is 780, but we're skipping it, so now go up to 840, 840. And then the next value is 900, but we're skipping it. And now we're going to go up to 960. Uh-oh. Is 1,000 going to fit? So the next number here is going to be 1,020. But it's going to be pretty hard to fit that on there. 1,020, and I can't fit it on. But, oh well. So basically I go up to 1,000. The 1,000 mark is about right here. Okay? Okay, on your graph, you need to label your axes. Label your axes. You need to tell me the units, like number of tickets or dollars. And I want you to draw your scale on the x-axis. Let's forget about the scale on the y-axis. I'll show you why in a minute. Oops, I can't spell when I'm talking. Scale. Okay, so do the scale on the x-axis. And in just a minute, I'll show you a trick on the y-axis that can save us some time. And then I want you to plot a point, maybe 1 or 2 points, I don't know. Plot your points, and then you need to draw the line that shows this is a proportional relationship. Okay, use the text tool for your labels. Now, let's finish the problem. They want to know how much they would raise if they sell 1,000 tickets. Let's go back to our notes. If they sell 1,000 tickets, then X equals 1,000. Now solve for the M value. Put 1,000 in the equation for X. So M equals 2.4, which means $2.4 per ticket, times 1,000 tickets. And do the math. It's very easy, isn't it? They will raise $2,400. $2,400. Oh man, do I have to graph and do this scale up to that? Well, I have another idea. Let's just say that it's at the top of the graph here, and this is $2,400. So that is the only thing I'm writing on the scale. I know my Y scale starts at 0 and it goes up to $2,400 for 1,000 tickets. So go ahead and put the point on your graph. Get the point tool, plot it on your graph. 1,000 tickets earns $2,400. Now draw a line. Can you draw the line? But teacher, how can I draw a line? I only have 1 point. Yes, but you know the other point is 0, 0. You know that because if they sell 0 tickets, they earn $0. Now, here's the graph. We put the scale on the x-axis, but we only wrote the scale here on the y-axis to save a lot of time. If you wanted to do the scale, you can. Let's count. How many tick marks are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There's 13 tick marks. So what would your numbers be if you wanted to put them on there? If you really want to spend the time, then that's 2,400 divided by 13 tick marks. So each tick mark would be $184. We could round that up and say 185. So each one of these would be like 185, counting by 185. I don't want to do that. I'm exhausted. I'm only putting 1. And that's what you can do too. You can save time and it makes sense. Just put your 1 here. It is 2,400. Oh, oops, it's down here. I don't know how I did that. There. Make sure you use the text tool and put that 2,400 wherever you chose. Oh no. Oh dear, look at that. I have not wrote a text somewhere. I have labeled a point. Let me get rid of that. I'm going to try again. Okay, right here. This is 2,400. Ding. Right there. Okay, you need to finish. Make sure you label this scale. I didn't do it, but you have to do it. Follow these points here and do it yourself. Let's go on to the next problem. Describe how you can tell whether a line's slope is greater than 1, equal to 1, or less than 1. How can you tell? Okay, well let me draw my x and y axes. There's my y axis and there's my x axis. Now if a slope is equal to 1, it means every 1 unit of change in y for every 1 unit of change in x. Sometimes that would be a 45-degree angle, but not always. What if you change the scaling here? Then it might look like this. This could also be a scale of 1. It could be like we sold 1 car. Wait a minute, that's a bad example. Okay, wait. Let's say we use 1 tomato for every 1 cup of salsa. I don't know, something like that. And my scale looks like this. So this is one tomato in my recipe for every 1 cup of salsa. And then 2 tomatoes is here, and this is 2 cups of salsa. So you could write the scale where the y-axis is squished down and the x-axis is spread out, and then it is not a 45-degree angle. So you cannot just look at the angle. If it is greater than 1, it has a proportional relationship greater than 1. And if it is equal to 1, then the change in x is equal to the change in y. If it is less than 1, it's going to be going down. Ta-da! So anything going up is greater than or equal to 1. Anything going down, no matter how steep it's going down, that's less than 1. So these slopes going down, they are a negative number. They are less than 1. I'll write it like that, less than 1. These slopes going up are either greater than 1 or equal to 1. Okay, I want you to type your answer here. And I didn't help you type it. Do you need me to help you type it? Okay, let me help you. It could be that you're not used to writing answers in math. I can help you. If the line is going up, its slope is either equal to or greater than 1. You have to look at the scale. If the line is decreasing or going down, the slope is... Oh, I showed you the negative slopes. Hold on. I explained this wrong. Okay, if this line has a positive slope, then you know it is a positive number. But what about the fraction 2/3? Okay, that is also a positive number, but it is less than 1. So actually, there's 3 categories. We could have a slope that is greater than 1. I'm going to put it here. A slope that is greater than 1. Like this. There we go. I'm forgetting what to do with my marks. I never thought about writing it out like this. Okay, wait. Okay, we could have a slope that is between 0 and 1. So the slope is k. The k is greater than 0, but it is less than 1. Okay, that's one scenario. Or we could have a k that is less than 0, and that is going to be equal to a negative k, a negative number. It's less than 0. Here, this is still a positive k, but it's between 0 and 1. And then the third scenario is a k that is greater than 1, and this is also positive. So that's what they're saying here. I wasn't thinking about it the first time I read it. If a slopes line is greater than 1, then you have this scenario. If a slopes line is equal to 1, k equals 1. Okay, it's a positive number. That could be here. It's equal to 1. And then less than 1, that could be this scenario as well. It could be less than 1 or it could be negative. Okay, so how can you tell? Well, you have to look at the scaling for sure. Because here, this k could be positive and it's, oops, not this one, I mean, this one here. This is a positive k, but it's less than 1. This is a positive k, but it's greater than 1. And then here is a negative k, but it's less than 0. So how do you know if you have a k greater than 1 or less than 1? You need to look at the scale. Don't just look at the angle it's going. So if the line is going up, its slope is either equal to or greater than 1. You have to look at the scale. If the line is decreasing, the slope is negative. Okay? Go ahead and you can copy my answer for that one if you want to. No problem. I'll give you a minute to write that down in your notes. Please write it in your notes and type it in GeoGebra. Let's keep going. Next problem. A line is represented by the equation y divided by x minus 2 equals 3 over 11. What are the coordinates of some of the points on the line? Okay, we definitely need to go to our notes for this one. We're going to need to write down some information. Let me go down. I think this was problem 4, wasn't it? Something like that, problem 4. Make sure you label it in your notes. Okay, the equation of the line is, and this is totally new to us, isn't it? I've never seen a line with an equation like this before. It's not in the form that I'm used to, but we can still use it just the same. So this is the equation of the line, and it says, what are the coordinates of some of the points on the line? So all we need to do is pop in numbers and find out what the other coordinate will be. So let's put in x values. If x equals 0, we will solve for the y. When x equals 1, let's solve for the y. When x equals 2, then that'll be funny. That'll be 2 minus 2. That's going to be 0. That's strange. Can we use that? I don't know. And then I'll use 4. In case the 2 is too startling for me, I'll use 4. Okay, let's put these numbers in. When x equals 0, pop that in right there, we get y divided by 0 minus 2 equals 3 over 11. So now simplify that. That's y divided by negative 2. Because 0 minus 2 is negative 2. Y divided by negative 2 equals 3 over 11. Okay, let's get rid of that negative 2 because we want to isolate the y. Don't forget, what you do to one side of the equation, you have to do to the other. I'm multiplying both sides by negative 2 because I want to cancel out this negative 2. And then when I do the math, I get 3 times negative 2 over 11, which is negative 6 over 11. Okay, when x equals 0, y equals negative 6 over 11. How about when x equals 1? I'm going to do that over here. Then we get y equals 1 minus 2 because I put in 1 for x. Y equals 1 minus 2. Sorry, not equals. Y over 1 minus 2 equals 3 over 11. That's an 11 there. Okay, 1 minus 2 is negative 2. So I get y over negative 2 equals 3 over 11. I want to solve for y, so I'm going to isolate it by getting rid of that negative 2. So multiply both sides by negative 2. Then these negative 2's cancel out. And y equals 3 times negative 2. Oh, I did it wrong. I'm so sorry. I just now caught my mistake. 1 minus 2 is not negative 2. I'm doing it wrong. I've made a mathematical mistake and I just kept going. I need to erase this. Did you catch my mistake? I hope you did. If you're following along, then you already caught my mistake. And you're like, oh, teacher's crazy. Okay, so let me get back to it. So this is why 1 minus 2 is negative 1 equals 3 over 11. Okay, let's simplify this number. What is y divided by negative 1? Anything divided by negative 1 is the negative of the number. So negative y equals 3 over 11. Now, I don't want to know what negative y equals. I want to know what y equals. So I'm going to multiply this side by negative 1, and I'm going to multiply this side by negative 1. So negative 1 times y gives me a positive y, positive 1y. And then over here, 3/11 times negative 1 gives me negative 3/11. Now fill in your table. Okay, what about when x equals 2? I'm going to get a denominator equals to 0. Well, what does that tell me? Y, oops. There we go. Y, and this is going to be 2 minus 2 equals 3 over 11. 2 minus 2 is 0, so I get y divided by 0 equals 3 over 11. But what is anything divided by 0? Do you remember? Anything divided by 0 is 0. Anything divided by 0 is 0. So I'm getting 0 equals 3 over 11? No, that doesn't even work out. So I think this equation doesn't work when x equals 2. That's a strange value right there, huh? It doesn't really work. Let's try 4. Okay, are you ready? Oh, you know what? Maybe y equals 0 when x equals 0. I don't know. Strange. I'm not sure about that one. Does y equal 0? We'll find out later. Yeah, in high school algebra, we'll find out. Okay, when x equals 4, let's do that one over here. So y, x minus 2, oops, the x is equal to 4. 4 equals 3 over 11. Okay, I'm exhausted, so I want you to solve this one. You're going to solve this one yourself. And the question asked us, what are some coordinate points of this line? What are some coordinate points that are on this line? Okay, well, we solved for them here in this table. But how are you going to write your answer in GeoGebra? You're going to write them as coordinate points. When x equals 0, y equals negative 6/11. There's one coordinate point. Another coordinate point, when x equals 1, y equals negative 3/11. And another coordinate point was when x equals 4, and then I didn't finish solving that. And I don't want you to just copy my answers anyway, so please solve that one for x equals 4. Go ahead and solve it, please. And then when you're done solving those, make sure you take a nice picture of your notes because you're going to turn that in with your assignment. It says here, graph the line. Graph that line. I want you to give it a try. So use this point tool and plot the points on the graph. Make sure you put on your scale. So you're going to need to scale this graph down here. And if you want to, just do something easy. Scale this y-axis here. Plot your points. Draw the line, or even, I don't know what the line is going to look like. I have no idea. And that's it. Whew. Okay. Good job, guys. Remember, I want to see your work. So you better take a picture of your notes that is clear and attach the picture file in the Google Classroom with this assignment. Okay, see you later.